Right, so it's important to know a little bit of function theory to progress with this course, because it will be necessary to do various different aspects. So let's just crack on with a little bit of formality. So we've got different types of functions, and actually a bit more broader than that is different types of mappings. So a function will take an input and change it somehow, changes it to an output. And this process is the same process for different input values, and you'll get a different set of output values, and this set of input values has a name, and the name that it gets is the domain, and the output is referred to as the range. So for example, if you had the graph of y equals x squared, then the domain would be any real number, and the range would be greater than or equal to 0. Because you can't get an output from that that's less than 0, okay, with the real domain. Okay? Now, what I've drawn here is I've got different values in my domain, so different input values, and they all go to their own output value. So this might be perhaps maybe a linear function, or an exponential function, or a logarithmic function, or perhaps it might be a certain type of cubic function, which doesn't have any turning points. The point is that there's no value in the range, or the output, that has multiple values from the domain going to it. So examples might be y equals x, or y equals ln x, or y equals a to the x for some number a. But there are different types of functions. So there's this one. Here we can see that there are two different values in the domain that go to the same value in the range. There are two different values in the domain that have gone to the same value in the range. So if you think of the graph of y equals x squared, I could have -2 and +2 that both go to the number 4. Okay? So you might have a quadratic, or certain cubics, or perhaps a trigonometric one, like sine or cos. Okay. And these two classes of function get a special name. So this type of function is referred to as a one-to-one function. One x value goes to one y value, and it's completely unique. I mean, you could look at the domain as being the set of x and the range of the set of y, which is why I'm saying x and y. This one is called many-to-one, because there are many values in the domain that go to one y value in the range. And all functions fit into one of those two categories. Okay, they are either a one-to-one function, or they are a many-to-one function. Okay? But there's more. What happens if you input a single x value and that actually yields multiple y values? Okay. It's not a function. You are right, it is not a function. It's referred to as a one-to-many mapping. It's referred to as a one-to-many mapping. not a function. And an example of this might be, well, let's just do y squared equals x. That produces a graph that looks something like that. Okay. So it's a parabola on its side. Okay, my y-axis and my x-axis. Okay, parabola on its side. That's a mapping, not a function. Or you might get a more complicated one where you have some x values which go to multiple y values, but you also have some y values which are obtained from different x values. Okay, so this y value here is obtained from this x value and from this x value, but this x value here goes to that y value and that y value. And this is referred to as, you might guess, many to many. And again, this is referred to as a mapping, not a function. This is a many-to-one function up here. And this is a one-to-one function. Many-to-many mapping. The clearest example of this one is a circle. Okay, you've studied the equation of a circle, that's why I've put that one in there.